Hello and welcome to this video delving into and then debunking one of the crazier conspiracy theories that overhead power lines cause a wide range of health issues and other problems. Of course, we're not talking about electrocution or similar direct problems, or rather that the sheer presence and activity of overhead power lines will cause you to experience health-related problems. For this video, let's operate on the premise that it is one of the larger power lines available, somewhere around 345 to 400 kilovolts, although they can go up to 800 kilovolts. Admittedly, these are not the biggest of transmission lines, but these are big transmission towers, made of girder steel. That's because it is a system able to conduct the most electricity and is at least insulated, at least as far as power cables go. The cables themselves don't conduct electricity through the air very well, and when they get to the towers themselves, they're separated by ceramic plates that prevent them from causing problems. Because we are talking about the largest towers, it means they should be the most likely to cause problems, if any can. The claims associated with overhead power lines are mostly focused on cancer and electromagnetic fields or radiation. Thankfully, both of these are real things, and we do have a solid knowledge of what they are due to modern science, so we can put the claim to test. First, we'll address electromagnetic fields, or electromagnetic radiation, a field just being the area in which you measure the electromagnetic force, radiation just being energy. For the purposes of this, we can look at it as a series of waves, and these waves basically get emitted from the power line, and so you get both synchronized oscillations and you get the magnetic field from this. In theory, electromagnetic waves should travel at the speed of light, but this is only true in a vacuum. In reality, the speed is considerably shorter, and as a result, we can measure them rather effectively. When we get electromagnetic waves, we can actually generate them a very simple way, and that's by running electricity through in this case, a linear piece of wire. When the electricity causes the particles to get charged and accelerate, they subsequently interact with other charged particles, and this ends up carrying the electromagnetic force. It's essentially a wave of power, albeit with a very limited range. This range can still interact with people, and anything else for that matter, so it's not as though it's a completely unfounded idea. But this does bring us to looking at what effect electromagnetic radiation or fields would have on, for example, biological organisms, like humans. It very much depends on the power and frequency, and this is an important distinction to make here. Lower energy or ultraviolet frequencies tend to be relatively innocuous. Innocuous in that they generate heat, not that they can't cause any harm. And these are classified as non-ionizing, and that's simply because they don't have the power to ionize an atom, a molecule, or to break something like a chemical bond. Generally speaking, the only thing they will do is cause heating, exactly the same phenomena you would observe in a microwave oven. On the other end of the spectrum, we have ionizing radiation or ionizing energy. X-rays, ultraviolet light, gamma rays, basically think of a nuclear bomb. Although, admittedly, you don't need a nuclear bomb for this to happen. You can get these from a range of possible mechanisms. You don't require nuclear weapons. The issue with ionizing radiation is that it can cause problems. It can penetrate deep enough into the human body that it can start to interact with living cells. This means you can not only get the issue of the living cell, and particularly the DNA, but also the chemicals within the cell and human body being reacted and therefore damaged. Now that we have a relatively clear understanding of what electromagnetic fields are and what it does, we'll come back to the relationship to overhead power lines shortly. Just bear everything we've mentioned in mind, particularly about the fact that electromagnetic fields are a particular set of things. We need to move on to cancer, which is the primary disease that's mentioned in relation to this. At its simplest, cancer is uncontrolled cell division associated with loss of cell function, wrong locations, and interfering with normal bodily functions. You could also typically say a tumor as well, as a tumor is technically just uncontrolled cell growth. It's generally not going to be as pathological, if pathological at all, and doesn't interfere with normal bodily functions, but cancer is generally used synonymously to mean both things. Just bear in mind, when we say cancer, we are using the synonymous meaning, not the actual meaning. The mechanism by which cancer happens can be broadly divided into chemical, energy, genomic, and environmental. These four mechanisms are both interrelated and interdependent. Chemicals are where we're talking about a problem with a chemical in the body causing damage to cells, leading to mutations. It can also cause disruptions to the DNA and so on. The major mechanisms are going to be things like cell damage requiring cells proliferate or replace themselves frequently, resulting in the cells eventually making mistakes in their DNA and therefore becoming, mutated. Energy causes mutations, and specifically in things like proteins and DNA. You can, in the same way as you could disrupt a chemical via the energy involved, disrupt proteins and DNA because, they are just chemicals. Specific types of chemicals, but chemicals nonetheless. Genomic is generally going to be attributed to issues around increasing cell proliferation, reduced cell division control, and a lack of cell division checkpoints and more. This is all done through altering the genes responsible for these functions. Finally, the environment, which can include exposure to things like radiation, but that would also be a form of energy issues, along with toxins and more. These very much come back to the first issues around chemicals and similar. It's just that it's not limited to only chemicals. It can be poor diet and things like that. It's more complicated, and certainly more holistic. This brings us to the crux of electromagnetic fields and how they cause cancer through energy genomics and the environment. We can, for the most part, ignore the issue around whether or not there is a genetic basis, as the genetic bases can be caused by these other three, so it's important to be aware of that. As stated, you can generate an electromagnetic field, and this is done by conducting a current through a parallel set of wires. This is how things like a generator will work, or you can even find various parts of your car that will do the same job. As a consequence of passing a current through a power line, you can generate a small charge or a magnetic field, depends on which way the energy is going. Energy going in produces magnetic fields. Magnetic fields in effect already generate electricity. Understand that due to the lack of windings by number, opposing directions, and the distances between the power lines, the actual measurable result is at least small by comparison to other examples like an electrical transformer and other similar specifically designed and made devices. This means that when we have a flowing current, as you will see with just about every set of power lines, it will form a magnetic field. When the current stops, it makes an electric field. When we base this situation on the largest typical pylon at about 400 kilovolts, what we get is 100 microteslas, or about 1 Gauss, at a range of roughly 25 meters each side of the power lines involved. So let's assume directly overhead, such as a house built under the power line. That means you're exposed to 1 Gauss a day. Now, this is a theoretical scenario, but when we actually look at a 400 kilovolt system, we find that that 1 Gauss number isn't quite right. When we look at published numbers for this, it turns out to be significantly lower, at 2.4 microteslas, or 0.024 Gauss. If we assume that all of the circuits or sets of wires overlap, then we would still only reach 0.048 Gauss. This is far below the 5 Gauss allowed for implanted devices like pacemakers, as in something literally in the center of your body, and if it's going to emit any issues, such as radiation that will cause ionizing problems, you're going to have it very, very, very low, if allowed at all. And in this case, we're talking about something about 1/200th of that allowed amount. Further to that, if we're going to look at something that actually has harm done to it, we need to look at something more along the lines of 10 Gauss to begin causing harm. Now, this is admittedly to objects like credit cards, magnetic tape, and similar sensitive items, but then again, if we look at those things and think, if they can be damaged or erased, theoretically, exposure to this would cause the same thing to the human body over time. But then again, that's also now 1/400th of the energy that you need to achieve this. This rather roundabout explanation gives us a rather straightforward statement that there's no obvious way for this to happen at this stage. But that's not all the possibilities. We need to talk not just about the power, because the power itself can be less important than the wavelength. And that's down to how the harm happens. As we mentioned, there's ionizing and non-ionizing radiation. Non-ionizing radiation are what you typically see with longer wavelengths. These are what will generate heat. Shorter wavelengths are what you need to worry about. These are typically going to be your ionizing radiation, and they can penetrate the skin and affect things like DNA. This brings us down to that gene regulation issue. Things like oncogenes, genes that are meant to prevent cells from turning into cancer. For what we're talking about, wavelengths at or below 10 nanometers are dangerous. That's because they are the ionizing frequencies, and they're what will lead to mutations in your DNA. But that's the thing here, we still don't have ionizing radiation being generated. And therein lies the crux of the problem with this so far. The lack of a reference and the ability to actually produce radiation of that kind is nil. And that's because the product and charge of magnetism doesn't create radiation in those terms. It does have a relationship, to a certain extent, with creating charged particles, just not that kind of radiation. What it does is create charged photons with almost no value in terms of ability to cause harm. This phenomenon has been investigated as a weapon, and the results from a militaristic point of view are disappointing, let's say. When you look at the attempt to apply this kind of setup in a military setting, what they basically have done is create a microwave oven that emits a beam outwards. It also requires about 2 kilovolts a meter for the weapon system to be, well, viable. And even that's found to be too inefficient, take too long, and require huge amounts of energy to actually run. And the theory, at least from conspiracy theorists, is that somehow or other electrical companies are allowing this excess electricity that they have had to pay for just be discharged into the environment. They're not quite that stupid, and no doubt their accountants would pick up very quickly that they're losing two important things. One is paying customers, but the second is energy they paid for that they're not getting paid by the consumer to use. There is one more possible way to generate the problem that's described by the conspiracy nutters. That is synchrotron radiation. Now, understand, this is a product of electricity, or more accurately, it's a charge traveling in a direction in a magnetic field. As this happens, the radiation is emitted and polarization will happen. Despite this, to get even remotely relevant amounts of this kind of synchrotron radiation, we need a particle accelerator or synchrotron. Both of these use immense amount of power and are well beyond power lines. Certainly in terms of what we're talking about, and already mentioned, power companies tend to not be a fan of wasting their precious electricity when they don't get paid for it. So far, we've addressed this as a purely mechanistic problem. That is, how can you make it happen? But there is always a possibility that we're not capturing everything, and this is true in some ways from research. The studies of data have found a very limited relationship. Understand, it's limited because just about every one of these studies is purely observational. They found a weak evidence of a relationship, but the problems with these findings are nearly always the same and are twofold. One, that every one of these studies is pretty much purely observational and therefore can only establish correlation and not causation. They're not trying to understand all the factors that come into play, which is very much the second issue. That other explanations of confounding variables have not and generally are not investigated. For example, properties under or near power lines tend to be far less valuable than other property. This contributes to those places lived in by those who are in lower socioeconomic statuses. In short, poor, uneducated, and working very unskilled jobs. The same people likely to develop complications from diet, environment, exposure, and so on. So, the issue here is that they haven't differentiated which of these groups is due to the power lines and which is due to other factors, and it creates a problem. The real-world studies, so to say, have indicated there's good reason to look into it, but not a mechanism nor a good relationship between power line exposure and other health issues like cancer. This is why, in short, there is no mechanistic way for overhead power lines to cause health issues. Yes, you may have anecdotes, but they mean nothing, as they are prone to all kinds of issues, something we've been through before. A large data is nice, but only when analysed in detail to ensure all confounding factors are accounted for. Otherwise, you can find all sorts of random things leading to meaningful results that once you analyse it properly, you find, oh, that was actually just background noise. Finally, there are just as many issues with underground power lines if overhead power lines are a problem, yet these seem to be magically immune to the same criticisms, almost as though this was an aesthetic problem, not a practical problem. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.